A/A. In the beginning, there was no form. There was only fire. We are looking at the universe when it was less than a trillionth of a second old. At this epoch, the cosmos was a place of perfect, terrifying symmetry. The forces of nature were indistinguishable. They were one. But the universe cooled. And as it cooled, that perfect symmetry broke. Think of a pond freezing over in winter. Ice forms in patches. Where two sheets of ice meet, they don't always align perfectly. They clash. They leave a jagged scar, a crack in the crystal. The same thing happened to the fabric of space-time itself. As the universe underwent this violent phase transition, regions of space cooled into different energy states. Where they met, the fabric didn't line up. It got trapped. These are not mistakes. They are relics, the scars of creation. Let us be precise. When we say string, do not confuse these with the microscopic loops of string theory that attempt to explain particles. Those are smaller than atoms. A cosmic string is a topological defect. It is a one-dimensional fault line in the universe, stretching potentially across the entire observable cosmos. They are thinner than a proton, a fraction of an atom's width. You could never see the string itself with the human eye, but do not let their size fool you. These objects define the word extreme. Because they are trapped in a high-energy state from the dawn of time, their density is incomprehensible. The mass depends on the energy scale of the symmetry break. But in many grand unified theories, a single kilometer of this string would carry roughly the same mass as the entire Earth. Imagine that. The entire mass of our planet, compressed into a filament thinner than an atomic nucleus. This extreme tension makes the string whip through the cosmos. So, how do we find something invisible? We look at how it breaks the rules of geometry. It creates what we call conical spacetime. Imagine taking a pizza and slicing out a wedge. If you were to fly a spaceship in a full circle around a cosmic string, you would find that a circle is less than 360 degrees. For us astronomers, this creates a unique fingerprint. If a cosmic string passes between Earth and a distant galaxy, light rays are forced to converge. The result is a very specific type of gravitational lensing. It produces two identical, undistorted copies of the same galaxy. For a brief time, we thought we found one. The object CSL-1 showed two identical galaxies sitting side by side. It was the perfect candidate. Further observation with the Hubble telescope revealed them to be two separate galaxies merely acting as neighbors. But the hunt continues. These strings are not static. They are violent. They thrash through the universe. And occasionally, a long string will cross over itself. When this happens, a loop is chopped off. This isolated loop is a death spiral of pure energy. It vibrates, oscillating frantically. And as it does, it radiates its mass away, not as light, but as gravitational waves. We have detected waves from black holes, but strings are different. Because they are everywhere, buzzing and decaying since the Big Bang, they should create a background noise, a stochastic background. To hear this, we use the galaxy itself as a detector. We monitor pulsar timing arrays. Pulsars are the universe's most precise clocks. If a gravitational wave passes between us, it stretches the space, delaying the tick of that clock by nanoseconds. In recent years, astronomers have detected a low-frequency hum. We are not yet certain if this is the song of supermassive black holes merging or the dying screams of cosmic strings evaporating. But the signal is there. The physicist Kibble first proposed the mechanism for how these defects form. He realized that if the universe cooled quickly enough, defects were inevitable. If we find them, it confirms that the forces we see today, electricity, magnetism, the nuclear bonds holding your body together, are just shards of a once unified superforce. Some theories even suggest that cosmic strings acted as the seeds for the galaxies themselves, that their immense gravity pulled matter together, forming the skeletons upon which our galaxy, our sun, and our Earth were built. They are the dinosaurs of physics, ancient, massive, and wandering the dark. To find one would be to touch the moment of creation itself. We are travelers in a broken universe. But it is in the cracks, the imperfections, that we find the truth of where we came from. A/A.